If you are a beginner in electronics like I was, and you should be curious by now about IC, aka integrated circuits, where they are mostly used for electronics projects like light detectors. You can see this LED coming on when it sends room light and going off when the light is being switched off or blocked in the room. Night switches, which works as the automatic street light, which only comes on only in the dark and goes off in daylight. So why not stay with me to the end of this video while I take you through the world of ICs. So one of the ICs I'm going to be really explaining in this video, and which we are going to be using to build some of our projects, is the well-known IC, which is known as the operational amplifier, which is also known as op-amps. They are all represented in a triangle form. Like this IC has 8 pins with 2 op-amps inside. So that means we either choose to use one side of the op-amps, but you could use the two if only necessary. They all come in different IC packaging, like this one still with 8 pins but 1 op-amps inside, and this one with 14 pins and we have 4 op-amps inside. Op-amps comes with 2 input pins and 1 output pin, where the negative sign is known as the inverting input and the positive sign is known as the non-inverting input. What this means is if we apply a signal at the non-inverting input pin, our signal is going to be amplified by the op-amp to a much higher gain, but which signal is in phase with its input at its output. But if we apply that signal at its inverting input, that signal will still be amplified at its output, but it will experience a 180-degree phase shift. The key point here of an op-amp is they are mostly used for amplifying signals. So op-amps has a lot of uses and more than what I will mention in this video. Example are the inverting amplifier and non-inverting amplifier, which I have already explained. The differential amplifier, a type that accepts 2 input signals and amplifies the difference between the 2 input signals, but suppresses any signal common to the 2 inputs. The summing amplifiers are commonly used to process analog signals. You mostly find this in audio mixers, which allows audio experts to combine signals from various channels and reproduce them into signal track. Most people like DJs. The clipper circuits. In short, they are used to remove positive half or negative half cycles of input signals without causing distortions to the remaining part of the waves. Peak detectors. The circuit is used to detect the peak value of an input signal, or in simple, it keeps a continuous track and hold the highest amplitude of the input signals. Comparators. One nice thing about this op-amp as a comparator is the uses for project that has to do with sensors like security alarm, dark activator switches, oscillators, motion sensors, and many more of these you could think of. We are going to be making some sensors project using this comparator. Comparator is a device that compares 2 voltages or current and outputs a digital signals indicating which is larger. Now let's say we have 2 input voltage. If the voltage at the non-inverting input is slightly greater than the voltage at the inverting input, the output of the comparator is going to output high, which will move up to the positive applied voltage VCC. But in the real world, this voltage is going to be limited by the op-amp because of some of the resistance in it. If the voltage at the non-inverting input is less than the voltage at the inverting input, the comparator is going to output low, which is going to ground 0 volt. So guys, before we go into the real world, the 2 identical resistors connected in series act as a voltage divider for the inverting inputs. So why are they identical? It's because it's going to give us half of VCC. So this point is called our reference voltage. The variable resistor at the non-inverting input also acts as a voltage divider, but one which its voltage could be varied. So guys, here is an op-amp. So I'm using a LM358. So I'm just going to hook things up. Connect the 8th pin of the LM358 to the positive rail. which is our VCC, and its fourth pin to ground, and place a 10k resistor between pin 8 and its inverting input pin 2, and it is identical, sending it to ground. And with your variable resistor, I'm using a 20k. Like I said, you're going to be using this to vary the voltage at the non-inverting input, and connecting the third lead of the variable resistor to pin 3 of the IC, which happens to be our non-inverting input, and also connecting its third leads to ground, and also connecting its first leads to positive VCC, which is at pin 8. Place the LED such that its anode is connected to pin 1 of the IC, and sending its cathode to ground. Pin 1 is the output of the op-amp. So with these pins, I'm going to be using crocodile clips so we can clip our multimeter clips to this to determine our output voltages each time we vary the signals. But wait, you could destroy this LED. We just can't hook LEDs like that. Our output would be so high, so we're going to need a 220 ohms resistor to limit the output voltage, so we'll not end up destroying this LED. Remember, too much current to an LED will cause a huge damage. So I've taken the anode out of the output and placed the resistor to the anode. After done that, apply your positive supply voltage. You can see already the LED has already turned on. So by varying our variable resistor clockwise, our output should go low, and taking that anti-clockwise, our output should go high. Now let's see this using the digital multimeter. And already our output is already high, so our voltage at the output is around 5.8 volts. Okay, let's see what's going to happen when we vary the signal. Taking that clockwise, you see we have a low output, which is the ground voltage, and taking that anti-clockwise, the output goes high to the positive supply voltage. Okay, let's take things the other way around. Let's see what our reference voltage is. So we're going to put that at the output of this voltage divider, and we see our reference voltage is around 3.7. so that voltage is less each time our voltage at the non-inverting input is greater, and that voltage is greater if the voltage at a non-inverting input is less. And already you can also see those signals displayed on the oscilloscope. So we are going to be using this to build a light detector. So when we have an LDR and also a variable resistor which acts as a voltage divider, so each time light falls into the LDR, the resistance drops, and each time the room is dark and there's no light, the resistance in the LDR increases. So here is an LDR. So we are just going to hook things up without wasting much of our time. So you're going to change the way we wire up a variable resistor. Place the LDR on the breadboard such that one of its leads is connected to the positive rails and one of its leads is connected to the middle leads of the variable resistor. And so we have our power supply inputs coming in, and we see our LED coming on because already we have room light. So if I switch off this, our LED goes off immediately, and if I turn on the light again, the LED comes on and goes off again when it detects the darkness, and and also still goes on with this light in the room. So let's go over to the next project. So we're going to need this bright light for night switch. So the only thing that changed here is just the LDR and the variable resistor. You can see we have the variable resistor up and the LDR down. So without wasting much of the time, connect the first list of the variable resistor to the positive rail, and with your LDR connecting one of its leads to ground and one of its leads pairing with the middle leads of the variable resistor. and hook up your power supply. Right now the light is on because we have room light. So when you switch off the light comes on, and when we switch on the light again, the light goes off. You can see that. So if you're new here, do not forget to hit that subscribe button, and also keep your notification bell on so that you won't miss other upcoming videos coming next week. And you can check out for our past videos on the description box below, and also stay creative.